All right, guys. Mr. Mayfield here. How you guys doing? Today we're gonna make another foldable. So we're gonna take this paper and fold it this way. Once you've got it folded that way, we're gonna cut it into 3 flaps. So they don't have to be perfect, but you want them to sort of be roughly even. So we'll cut 1 flap there, and then 1 cut right there. Now we have 3 flaps. Okay. Now this foldable is going to be all about thermal energy transfer. And there's 3 different ways that thermal energy can transfer. And transfer is just a fancy way of saying that the thermal energy is moving from one place to another. So the first way is convection. The second way is radiation. And then we have conduction. So those are the 3 ways that thermal energy can be transferred or moved. So first thing we'll talk about is convection. So we'll open up this flap right here, and let's zoom in here. Convection is the transfer of heat by movement through a medium like air or water. So we're going to write that. Okay. So it's when heat moves through a medium. So when it says the word medium, we're talking about some type of matter that it has to move through. So this usually ends up being something like air or water, although it could be other mediums like in the Earth's crust. Underneath the crust is the mantle, and there's a rock that is solid, but it kind of moves like a fluid because it's so hot, and convection happens there. So anytime you have something that can move like a fluid, whether it be a gas, a liquid, or a solid, and you have a heat source, it can move heat through it in this method, convection. Okay. And what causes it to move is changes in density. When something gets hot, it becomes less dense. If something's less dense, that causes it to rise. When we study density, we know that something that's less dense will float. Okay, so things rise when they're less dense. And things that are colder become more dense. And that causes that substance to sink. Okay, so we have something that's hot rising and then something that's cold sinking. So let's illustrate this. Okay, I'm going to draw a pot. It's a beautiful pot. As you can see, I'm very gifted when it comes to art. Okay, and then underneath it, we're going to draw a flame. Okay, so this is like, the flame from a stove, and it's rising up and touching the bottom here. Now, let's say there's some water in this pot. Well, the water near the bottom is going to get heated up first. So the water near the bottom is going to be forced upward, because as it gets hotter, it becomes less dense and it will rise. Meanwhile, the water up top is cooler, so the hot water rising up will cause this cooler water to sink down like this. And then it becomes a cycle, because now this cooler water is near the bottom, which is near the heat, and that will cause it to become hotter and rise up, and then it'll push that water down, and this will continue to circulate up and down like this. So that's how convection works right there. Next, we'll look at radiation. So radiation's a pretty unique one, because out of these three methods, convection, conduction, and radiation is the only one that doesn't require a medium or some type of matter to move through. Okay? So we'll say that radiation is the transfer of energy along electromagnetic waves. For example, light waves, radio waves, microwaves, and we could go on. Those are just three examples of types of electromagnetic waves that can be that can carry thermal energy via radiation. Okay, so the key thing to remember here, or what's really important, is that there is no medium required. Okay, no medium means there's no matter. It can move through empty space. Now, if you remember, with convection, it has to have a medium like water or air or some sort of matter to move through, whereas radiation it can move through empty space. It does not require a medium. So we're going to write can move through empty space. All right, so an example of this would be like if you're around a campfire. So I'm going to draw some logs here. They're going to be, again, very beautiful logs, because I'm so talented when it comes to drawing. And I don't expect you guys to be able to draw quite as well as I can. But here are our logs. So as you can see, there's a beautiful stack of logs here. And we'll say that we've lit them on fire. So I'll draw this flame on here. Okay. So there's our flame. And if you've ever been near a fire, you don't have to put your hand in it to feel the heat. If you put your hand or your body near the side over here, you're going to feel heat coming off of it. And that's because of radiation. You see, this the fire is putting off electromagnetic waves in every single direction. So no matter where you stand, as long as you're close to this, you're going to feel these electromagnetic waves. And that's when you know, if it's cold outside and you're standing next to a fire, you feel the warmth or the heat coming off of the fire. You're actually feeling electromagnetic waves. So the heat is getting to you through this method, radiation. Okay? So anytime you put your hand near something and without touching it, you can actually feel the heat on your hand, or your body feels heat. You're feeling radiation. Thermal energy is transferring via radiation. And this would be moving through the air, but it's important to remember that it doesn't need air or water or any type of matter to move through. No medium. It can move through empty space. Next up, we got conduction. Now, this is the last of the three. And conduction requires a medium. It has to have some type of matter to move through. So we'll explain it like this. Conduction is the transfer of heat between objects or substances that are in direct, now this is important, direct contact with one another. Okay? So basically that means the two objects have to either be touching or, if we're just talking about a substance, okay, say like a pot that's made out of steel, if you heat up one end of the pot, the thermal energy can move through the substance because, it's all touching. All of the molecules are touching one another. So an example of this would be like a cast iron skillet. Again, prepare to be blown away by awesome art skills. Okay, so this is going to be a skillet. Okay, so there's our skillet. Now keep in mind, a skillet is made out of iron. Okay, so here's our skillet. And we're going to put a fire under this. This is the heat source. Okay, so the fire is going to touch the metal on the skillet right here. And I'll draw some arrows that represent the heat. So the heat will first move into the bottom because that's where the heat is being applied. Now, as time goes by, these arrows will move up. The heat will move up or through the material. Now, eventually, of course, this part's going to get hot right here, but eventually, these arrows that represent the thermal energy making their way through the skillet will even start to head in this direction. Now, this will take longer, but it will happen. The thermal energy will move through the handle of the pot this way. Okay? So this spot will heat up first, and then this spot will heat up next, and then it will continue to move on this way, right here. Okay, so keep in mind, this requires a medium. In this case, the medium would be the pan. All right? Thermal energy cannot move through empty space via conduction because conduction will always require some sort of medium or object for it to move through. If you took your finger and touched this, well, your finger and the hot pan are now in direct contact, so thermal energy would move out of the pan and into your finger, okay, because they're in direct contact. The thermal energy is moving through the metal in the pot because the metal is in direct contact with the other metal molecules, okay? So to recap here, thermal energy can move in three different ways: convection, radiation, and conduction. Convection and conduction both require a medium or some type of matter for the energy to move through. Radiation is unique in that it requires no medium. It can move through air or water if it needs to, but if it's in empty space where there's no matter, it can still move through empty space. So this is, for example, the sun. is millions and millions of miles away from the Earth, but the heat from the sun makes its way to Earth. Now, is there any air or water or any matter between here and the sun? Not really, but radiation allows the heat to travel through empty space and make its way to Earth. Convection works because of density. The area closest to the heat becomes hot, which causes it to be less dense and rise to the top. Meanwhile, the cooler matter near the top is going to become, well, it's already cold, so it's going to be more dense, and that's going to cause it to sink. And then that's going to cycle through. And then finally, conduction. We're talking about thermal energy moving through something because it's in direct contact with the other object. So you're going to glue this into your IMB. I'll let you know in class what page to glue that into. And that's conduction, convection, and radiation.